Hey class, this is lesson 532. We're going to look at one more shortcut we can use for multiplying binomials, and this is called squares of binomials. And something interesting happens when you multiply something like this, where you have exactly the same two terms in each binomial, but one is subtraction and one is addition. And I'll come back to that, but let's just try a couple here real quick. So let's say I have x minus 2 times quantity x plus 2. And I use the FOIL method, so I take the first two, multiply them, that gives me x squared. Take the outside two, and multiply them, that gives me 2x. Now I take the inside two, these two, and multiply them, and that gives me a negative 2x. And then I take the last two and multiply them, and I get a minus 4. And then notice this, that the 2x and the minus 2x make 0. So I end up with x squared minus 4. So, and you've noticed that almost always when we multiply two binomials, we get a trinomial. But this is the one case where you multiply two binomials and you actually get a binomial. And it's a special case. This has to be true. So you have exactly the same two terms, except one is addition and one is subtraction. So in general, we can use this idea that we're going to get, and I'll expand this out so you can see. So multiply the first two, a times a is a squared. Multiply the last two, a times b, and we have a minus sign here. So that's going to be minus ab. And then I'm going to multiply the inside two, which is those two. And that's plus ab. And then I'm going to multiply the last two, which are the two b's. And one is a positive and one is a negative. So that gives us a minus b squared. Then those two terms zero each other out. So I end up with a squared minus b squared. All right, let's try that on a couple problems. So right here, and this will only work if those two terms are exactly the same. Those two are the same except they're opposites. So then I can use this. So all I have to do is take x times x, which is x squared, 10 times 10, which is 100, and subtract it. So I'll do one more with you here. Let's do this. And remember, this only works if you have the same first term and the second term are opposites. So we do 3y times 3y, and that's 9y squared. And we do 7 times 7 is 49, and we subtract those. And that's all there is to it. So number 2 says, how are the factors of the original products in exercise 1 similar? And the way they're similar is that they all look like this. They're all like this. And so the factors are the exact same two terms, just one is addition and one is subtraction. So we can kind of say they are opposites. So the same two terms, but one is opposite. So how are the expansions of the product similar? In every one, you will notice that the first number is squared and the second number is a perfect square. So this is a perfect square. 9y squared is 3y times 3y, and this is a perfect square. 49 is 7 times 7. So you get, in all of them, you get the difference of two squares. All right, and so If we expand this, we want to show that the pattern you notice will always be true for this kind of product. So when we use variables like that, we're saying any numbers, x and a, such that we have the quantity x plus a times quantity x minus a. And if I use the FOIL method, so I'm going to multiply the first two. X times x is x squared. Multiply the last two. And we have a minus sign right there. So that's minus ax. And multiply the inside two. And that's plus ax. And then we're going to multiply the last two. And that's minus a squared. And those two cancel out. And so we get x squared minus a squared. So that proves that it's always true. All right. So now it said if the expression fits the pattern of products in exercise 1, expand it using the pattern you described. If it does not fit the pattern stated in your answer. So we have to make sure that we have that those two numbers are exactly the same. Those two numbers are exactly the same. And then we have one that's plus and one that's minus. So A will work. So we'll just say yes, that works. And then we can just do x squared, 20 squared, which is 400, and subtract. Now I'm going to try and find one that doesn't fit it right here. This one does not fit it because those are the same, and those are exactly the same. They're not opposites. We have a minus 2.5 and a minus 2.5. So we cannot use that, the difference of two squares idea there. So we'll finish the rest of these in class. If you want, you can go through and pick the ones that you think you can use this idea. And the idea we're talking about is this, that a plus b times quantity a minus b is equal to a squared minus b squared. All right, number 6 says find two binomials with a product of x squared minus 49. Well, since it's a difference of two squares, we can think of what we just learned, where one is addition, one is subtraction, but the numbers we multiply are both the same to get the x squared, and the square root of 49 is 7, so 7 times 7 is 49, and that idea we can use there. All right. You guys, one of the things that we can use this for is to learn how to we can calculate some things in our head without a calculator. And we can use both the ideas we learned in lesson 531 and the ideas that we learned in lesson 532. As long as the numbers we're multiplying fit the patterns that we're using. Like 99 times 101 is 99, you might notice, is one less than 100. 101 is one more than 100. So let's just write it like this. 100 plus 1, that's my 101. And we want to multiply that by 99, and 99 is 100 minus 1. You might say, well, why did he do that? And the reason why is so that we have those numbers are exactly the same. Those numbers are exactly the same. So all I need to do is multiply 100 times 100, which I can do in my head. It's just 1 followed by 1, 2, 3, 4 zeros. And minus, because this is the difference of two squares, 1 times 1, which is 1. And I can do that in my head. That's just 9,999. So 99 times 101 is 9,999. Didn't need a calculator. Okay. I'll show you one more example like that. Pick something like, let's go with this one. 4.1 times 3.9. Some of you are thinking there's no way you can do that in your head. But if you think of it as 4 plus 0.1 times quantity 4 minus 0.1, well, now it's the same number there, the same number there, and so we can just do 4 times 4, which is 16, minus, then I have to just do 0.1 times 0.1. You can do that in your head. That is 0.01, and then I can subtract that. 1/100th minus 16 minus 1/100th is just 15.99. All right. The rest of these we'll work on in class. All right, let's do one more problem here, and then we'll call it a lesson. So on number 20, if you combine the difference of squares method of fast calculation with some other mathematical tricks, you can do even more computations in your head. Consider the product 32 times 29. Explain why 32 times 29 equals 31 times 29 plus 29. Well, here you have 29 31 times, and if you add 29 one more time, that's 29 32 times. So that's why 32 times 29 is equal to that. Okay? Now we can use the difference of square pattern to help us do that part, the 31 times the 29 part. So we can just do 31, we can think of that as 30 plus 1, 29 is 30 minus 1, and then we're going to do 30 times 30 is 900, minus 1 times 1 is 1, so that's 899. And then it says to use the product of 31 and 29 to compute 32 times 29. So we now have 29 31 times. We just need 29 one more time. So we have 899, and then we need 29 one more time, so we're going to add a 29. And if I was doing that in my head, I would just add 30, which would give me 929, and then subtract 1, and that gives me 928. All right? So it says compute 21 times 18 in your head. I'll get you started on that, but if we had 21 times 19, then we can write it as a difference of 2 squares. But if I multiply 21 times 19, I've multiplied 21 one extra time compared to the times 18 times that I want. So I'm just going to subtract 21 then when I'm done. And this 21 times 19 you can write as a difference of 2 squared. So I'm going to let you finish that, and we're going to call it a lesson, and I'll see you tomorrow.